1.10a Absolute value functions as piecewise functions. Today, students will rewrite absolute value functions as piecewise functions. Example number 1. Notice that the absolute value function to the right, f of x equals the absolute value of x, consists of two rays with a common endpoint at the origin. Let's examine each of these rays separately. The left ray, which is blue, where x is less than or equal to 0, has a slope of -1 and a y-intercept of 0, 0. It is part of the line y equals -x. Then when we look at our green ray, or the ray on the right, where x is greater than 0, it has a slope of +1 and the y-intercept is 0, 0. And again, it is part of the line y equals x. We can rewrite this function as a piecewise function. We have two pieces, a blue piece and a green piece. So if we take the blue piece and we write that equation, f of x equals, we're going to put the -x in our top part of our function, and then we are going to specify the subgroup or where that line is graphed, and it is all the x values less than 0. We then are going to take our green line or our green ray and write that function below it. So you can see we have f of x is equal to x only where x is greater than or equal to 0. So if you look at your x values, our green line or ray is only graphed where x is equal to 0. We could also switch our inequality symbols around and put for our -x line, x is less than or equal to 0. And for our positive slope, x is greater than 0. For this function, we get to choose whether the equals 0 part goes on the left ray or the right ray, but we have to pick one. So your inequality symbols in all of your piecewise functions for absolute value are going to have one of the inequality symbols with an or equal to under it. A piecewise function is a function that is defined by two or more subfunctions, each having its own interval of x. And we call that our subdomain. So when we use our inequality to state where our line covers, we call those subdomains. And when we split our absolute value into two separate equations per se for each piece, we call that our subfunctions. Example number 2 says rewrite f of x equals the absolute value of 2x minus 4 as a piecewise function. So the first part of this, it says at what x value does the graph turn? This helps us identify the subdomains. So looking at our graph where the blue and green ray meet, we have x is equal to 2, so we would say it turns at +2. The second piece says write the equation for the two lines. Extend the ray if you find that helpful. So looking at my green ray, I can tell that my y-intercept is at 4, so I'm going to have y equals something x plus 4 because that's where my line begins. And then when I take a look at my slope, I notice it goes down to right 1. So my slope is -2 over 1. Looking at my blue line, it's a little bit difficult for me to see where it crosses the y, but I can take a look at my slope first. It rises 2 and goes over 1, so I can then do the opposite of that and mark on my y-axis what my y-intercept would be. So in this case, I would have y equals, we said our slope was, it rises 2, runs 1, x, and our y-intercept is -4. So then what we're going to do is we're going to put the information together, writing the piecewise function. So first we want to start with our subfunctions. So we're going to use function notation, which represents y. We're going to set that equal to this fancy little parenthesis, our first function was negative 2 over 1x plus 4. Our second subfunction was positive 2 over 1x minus 4, and then we want to set our subdomains. So our green line only was where x was less than 2. So you're going to use your turning point when you're setting your subdomains. And our blue line, we're going to say x was greater than or equal to 2. So remember, you choose which inequality you want to set or equal to. And when you look at these numbers right here, you are going to use your turning point to determine those values. So let's try example 3. Rewrite f of x equals the absolute value of x minus 3 minus 2 as a piecewise function. So we first want to take a look at our graph at where our graph turns. So in accordance to our x-axis, our graph turns at positive 3. Write the equations of the two lines. Well, my line coming from the left, I can see crosses my y-axis at positive 1. And my slope in this one, I can see I'm falling 1, running 1. So it's 1 over 1. In my second ray, it's a little bit more difficult to see, but I can see that I'm rising 1, running 1. So if I trace that down to my y-axis, I can see that I am at negative 5, so we get y equals positive 1 over 1x minus 5. So don't forget, on this function you were falling, you were going down 1 over 1. So when we put that information together, we have f of x, which represents our y's. We're going to set that equal to our subfunctions. Our first subfunction was negative 1x plus 1. Our second subfunction was 1x minus 5. We then want to state their subdomains, so we're going to use our where our turning point is. So we're going to say where x is less than 3 for our top function, and then our right ray, or the blue one, we're going to say x is greater than or equal to 3. So we only graph that piece of the line. Example number 4, if we rewrite f of x equals the absolute value of 3x minus 3 plus 2 as a piecewise function, we look for our turning point so we can see that that is where x equals 1. So we know when we write our subdomains down here, we are going to have where x is less than 1 and where x is greater than or equal to 1, because we always use that turning point. If we write our two equations for the lines, if we look at this left ray, we can see that it crosses our y-axis at positive 5. We then need to take a look at our slope, and we're falling 3 or going down 3, running 1, so we have negative 3 over 1x for our first ray. Our second ray, or the right-hand side, I can tell that I'm rising 3, running 1, so if I go down to my y-intercept, I get y equals, we said we were rising 3 over 1x, and it crosses our y-axis at negative 1. We then put those pieces, so 3x minus 1 as our ray on the right, and negative 3x plus 5 as our ray on the left. Example number 5 says rewrite the function f of x equals negative x times the absolute value of x plus 2 plus 1. So you notice this negative flipped our absolute value graph over. You can tell that this 2 shifted our graph, or translated our graph 2 to the left, and this 1 moved it up 1 from the origin. So looking at our turning point on this one, if we transfer our turning point down to the x-axis, our turning point is where x equals -2. If we write our equations, when I look at my ray on the left, I'm rising 1, running 1. So if I take that all the way to my y-axis, I get y equals 1x plus 3. Looking at my other ray on the right-hand side, I can tell that it is going down 1 and running 1, so my slope is -1x, and it crosses my y-axis at -1. When we put the information together to write our piecewise function, we have f of x. We're going to put both of our pieces in one function. So our sub-function, our first sub-function was 1x plus 3, and the blue side of that was where all the x values are less than -2. Looking at our ray on the right, we have -1x minus 1, and that is where all the x values are greater than or equal to -2. Remember your inequality signs, you can pick which one is or equal to, and they must be different.